C equals minus pi case.
C equals to minus pi. Yes.
It should be 1 by 2 pi integral minus pi to pi, no, sir.
No, ma. See, C equals to minus pi means the interval should be of the form. Here it is minus pi to pi, right? So it is 2 divided by either a naught or a n or b n, whatever. Suppose a naught means 2
Yes,
divided
sir.
by
Pi
pi
minus of minus.
minus pi. So what will be you are having 2 divided by 2 pi. So over 1 over pi.
Right, right.
So period is here it is 2 pi. See, if you are maintaining that in all these things, here it is period is 2 pi. Here it is period is 2 pi. Here it is also period is 2 pi. And here the interval, if you are maintaining the period is 2l. Here it is period is 2l. Okay, here it is also period 2l. Is it clear?
Yes, sir. Got it, sir.
Yeah, fine. So that's the case. That's the case here we are having. Okay, so it is based on the function, whether it is given, whether in this which interval they are defined, whether it is minus pi to pi, this is 0 to 2 pi, and this is the formula for minus pi to 5. So if it is pi form, then the formula will be for the or the Fourier series will be, this is the corresponding Fourier series. But this a naught a n b n Euler's formula will differ. Is it clear?
Yes, sir.
Okay, this is my Fourier series. Okay, now we will check. Okay, how to write a Fourier series? Now, consider this function. Consider this. Actually, this is a graph they are given. It is from minus pi to 0. It is 0. Then pi. This is 0 to pi. It is pi minus x. This is my function. For these functions, we need to find the Fourier series. Okay, expand this function in terms of your Fourier series. Okay, what is about period? Can you tell me period? Period is pi minus of minus pi, which is 2 pi. Am I right? This functions which is defined in the interval, which is pi form. Is it clear?
Yes, sir.
So the corresponding Fourier series, can you tell me? Which is a naught by 2 plus sigma n from 1 to infinity cos an cos nx. Am I right?
Yes, sir.
Yes, sir.
Sigma n from 1 to infinity bn sin.
Sin nx.
Where a naught is half of the period, right? Half of the period, which is 1 by pi. And then it is defined from minus pi to 0. Sorry, actually minus pi to pi. So the formula will started with minus pi to pi f of x dx. And then my an is 1 by pi minus pi to pi f of x, which is cos nx dx. And then my bn will be 1 by pi minus pi to pi f of x sin nx dx. So this is the corresponding formula. So this a naught an bn will calculate here, but this minus pi to pi will be divided into this two interval. Okay, because of
Yes.
this. So in this way, in this case, my f of x is 0, and in this interval, my f of x is pi minus x. Using that, just integrating. Okay, this is the smallest case. Okay, so this you can integrate this one, but the lengthy one I will do. The lengthy one definitely I will do. So this is my a naught, a n, b n. So what is my Fourier series with this? With this, my f of x is what? Actually, the given function is, this is 0 and pi minus x, where 0 less than x. Sorry, minus pi less than x less than 0, and 0 or less than x less than pi. This is my f of x, and this is my f of x. This f of x now it is going to be expressed as a naught by 2. This is a naught by 2. So this is my a naught. A naught is pi by 2, and a naught by 2 means it is pi by 4. Is it clear? So it is pi by 4
Yes.
sigma n from 1 to infinity. What is my an? An is defined in this way, 1 minus of minus n, and even this also can be written as okay, after substituting here we should know the basic things. What is sine 0, sine n pi, sine 2 n pi, all are 0, right? Is it clear?
Yes, sir.
Okay,
Yes,
cos
sir.
0 1, and cos n pi minus 1 to the power n, cos 2 n pi, cos 2 n pi minus 1 to the power, this is 2n So for any n, it is an even number. So cos 2n pi is 1. Is it clear?
Yes, sir.
Okay. Now this an can be written as when n is even. Substitute some even number, then this should be positive, right? 1 minus 1, it is 0. When n is odd number, so this is one. Odd number means this is negative, right? What about this 1 minus of minus to the power 3? So 1 minus of minus 1. So it is 2. Okay, so overall it is 2 divided by n square pi. Is it clear?
Yes.
Okay, now we are going to write this as n runs from 1 to infinity. This case for n is for odd cases. Okay, n odd cases are n equals to 1 comma 3 comma 5 up to this infinity case. This can be written as my an will be 2 divided by n square pi into cos nx plus sigma n from 1 to infinity. My bn is, which is 1 by n, 1 by sine nx. Okay, so actual meaning of this what? So this is my f of x. I substitute this a naught by 2, which is pi by 4. And now when n is 1, when n is 1, when n is 1, when n is 1, okay, this 2, 4, 6, okay, this is infinity. So this is 0 into sin cos nx, okay. So okay, this is 0 into cos nx, 0 into cos nx, which means that all the even terms which is vanish. When n is 1, substitute that. When n is 1 means 2 divided by 1 square pi cos x. And when n is even, when n equals to 2, it is 0. Then when n is 3, 2 divided by 3 square pi cos 3x. And this is when n is even. Then when n is odd, so it is pi square by 5, it is cos 5x. It goes on. But whereas this, when n is 1, when n is 1, this is n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equals to 5. Okay, n equals to 1 means it is sine x by 1. And this is when n is 2, it is 1 by 2 sine 2x. When n is 3, 1 by 3 sine 3x. When n is 4, 1 by 4 sine 4x. When n is 5, 1 divided by 5 sine 5x. Is it clear? So this is my a naught by 2. This is my an cos nx, and this is my bn sin nx. With this, the even number of terms are vanishes, whereas this odd number of terms are present. So this f of x is, it is 0 and pi minus x form. This can be represented as this entire interval minus pi to pi, the periodic functions. In this way, as a combinations of this cosine and sine functions. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So in this way we can write. So let us consider this problem, the graph of the each of the following functions. See, if you are giving only these functions, we have to write this function, and this is the very dark one it is given means, which means that the height will be here, it is 3, and this height also here it is 3, the height of the functions, which means that this is 3 and this is minus 3. This is 3 and this is minus 3, so that the length of the interval, how they are going to take it. Okay, this length of the interval, okay, it is 5 minus of minus pi. So my period is which is 10. Okay,
Yes, sir.
okay,
Yes,
this is
sir.
L. Okay, so the functions given the problem, given the problem as L form, L form. In particular, okay, in particular, which is defined on minus L to L. This period is, here period is 2L equals to 10. So that my L is this 10 divided by 2. My L is 5. So that if this problem is defined on this problem number, which is minus pi to pi. Is it clear?
Yes, sir.
Which is defined on minus pi to pi. So what about the corresponding Fourier series solutions? Can you provide that? Let the Fourier series be. Let the Fourier
A
series,
naught by 2.
first Fourier series. First you have to say that the Fourier series, yeah, that is a naught by 2 sigma n from 1 to infinity. This a0, a1, b1 are Euler coefficients, Fourier coefficients. Okay, this a0, a1, bn are Euler coefficients, where n equals to 3 means nothing but we have two constants, a3 and b3. N equals to 100th term, if you want to compute, means a100 you have to compute. Generally we need to compute this an, with this a100 we able to get, or a100 means it is 1 by pi minus pi to pi. If it is minus pi to pi, f of x, it is cos 100x, we are going to compute it. Are you got the point? How we are computing this Fourier coefficients?
Yes, sir.
Okay, this a0, an, bn is, it's a generalization of all the coefficients of Fourier coefficients. Fourier coefficient, it's a generalization of all the Fourier coefficients. N means any number you can assign. Okay, so that's a general Fourier series. So okay, now let's come back to this problem. Let an is this is n from 1 to infinity, means what is that exactly? An L form means it is cos n pi x. L is here, it is 5. Okay,
Yes, sir.
so that the same, once you computed the same, here you may write, then a0 1 by L. Okay,
minus a to f of x dx.
which is minus 5 to 5
F of x dx.
Yeah. So for this 1 by 5, minus 5 to 0, which is minus 5 to 0, minus 5 to 0, my function is having the negative value, which is
minus 3.
minus 3 into dx, where it is 0 to 5. The graphical it is 3. It is 3 into dx, so that it is 1 by 5. 1 by 5, it is minus 3 into x of this limiting cases only you are substituting. Okay, limiting cases only we are going to substitute, so that minus 5 to 5, it is 0 minus 5. 0 minus 5. No, minus of minus 5. Am I right?
Yes, sir.
Okay, so that this is 1 by 5. 1 by 5. Can you tell me this is minus 15 and this is positive 15? Oh, it is 0. Okay, my a naught is 0. My a naught is 0. Whatever it may be. What about my an, which is 1 by 5 minus 5 to 5 f of x cos n pi x by 5 into dx. Okay, sir. So this kind of things, if you need, we need to have one formula which is called Bernoulli's formula. Do you know that?
Yes, the integral
Integration.
u dv is equal to
Yeah. Integration by parts. What is the problem? Integration by parts means integral of u dv means uv minus integral v du, right? Which means that here it is only one function. Function of x is u. Okay, and it is derivative of v. It is we are having in this way, but product of two functions. Product of two functions, so that u into integral of v dx, integral of v dx, and then it is u dash du by dx of integral whatever you are having, this is okay, integral of this v dx again. Okay, I may written in this way so that you may confused it. Okay, so here integral of udv means, here it is udv means u v1 minus u derivative v2, here alternative sign, plus minus plus, u double derivative v3 minus u triple derivative v4. Keep on going, where this u dash means du by dx, u double derivative means it is d square u divided by d square dx square, nothing but d by dx of already what you computed, this du by dx. Okay, d by dx of this u derivative alone, like that it goes up. And v1 means integral of v dx, v2 means integral of v1 dx. The same one we are going to integrate. V3 means integral of v2 dx, and so on. Okay, so just we should have this formula. Now you can understand, this can be 1 by 5 of minus 5 to 5 sorry, it is minus 3, right? F of x is here, it is minus 3. Since it is a constant function, no issue, no issue. Plus pi to 0, 3 into cos n pi x by 5 into dx. Okay, now which is 1 by 5, 1 by 5. This is minus 3 into integral of cos n pi x is what?
Sin n pi x by 5 divided by n pi x by 5.
Derivative of n pi by x, right? And it is 5 to 0, 0 to 5, 0 to 5. Yeah, okay. Now this 3 I will take out. Okay, so overall it is 3 by 5 minus this 5 divided by n pi. I'm going to take it. Okay, here also 5 divided by n pi, so that also I'm going to take it. Okay, as a common part. Okay, into 5 divided by n pi. So minus of this sine 0. This is sine
0 minus
minus sine of n pi minus pi divided by pi. Is it clear?
Yes.
s sir.
So this will be sine of minus theta is minus sine theta. So sine n pi here we are having. Is it clear?
Yes, sir.
So overall it is 0. This is also 0. So this term will vanish. This term will vanish. Okay, now it's this one. This already be taken out. This minus pi pi. Okay, then remaining it is when x equals to 5. This 5 pi and cancels. So sine n
Sin
pi.
n pi
Sine n pi. Okay, minus sine 0.
0.
Oh, okay, overall all these things, this also 0, right?
Yes.
So what about bn? What about bn? Can you say me? This is n pi by will come. So pi divided by n pi. Okay, this is a constant. Sir, I will take from the previous things itself. Okay, take its advantage to write the fast manner. So it is minus cos n pi x by pi. Is it clear? And already here one minus is there. Integration of this minus will give positive. Okay, and plus integration of these things, it is minus cos n pi x by pi. Am I right?
Yes, sir.
So this limit is minus pi to 0. This limit is 0 to pi. Okay, so this is the thing we are having. Substitute the limits. Substitute the limits. Cos 0 is 1 minus of cos minus pi, since cos of minus theta is cos theta, even function. So 1 minus of cos n pi plus, and here one minus is there, so I may write it as minus. Then it is cos pi. If I am substituting cos n pi, this is cos n pi minus this minus already be taken out, so that it is cos 0. So overall that it is 3 divided by n pi. It is 1 minus cos n pi minus cos n pi minus 1. So this and this get cancels, so that cos n pi is, since cos n pi is minus 1 to the power n, so
So
it is,
isn't it plus 1 minus into minus becomes plus, so
oh,
it
it is
will be
plus 1.
2.
Okay. So it is 2. Okay. So it
Yes.
is 2 minus 2 times of this minus 1 to the power n. Overall it is 6 divided by n pi into minus 1 minus 1 to the power n. So this can be written as, we can, if it is minus 1 power n, if it is have an, okay, we may write it as even number and odd number property, so that when n is odd, When n is even, 0. So this is my Bn. Okay, so B1, 3, 5, the coefficients may have the value 12 divided by n pi. This B2, 4, B2 or B4, B6, all that coefficients are having the value 0. So the required Fourier series Fourier series B, I will write in the expansion format. Okay, A naught is 0, A naught by 2. Since this is A naught by 2, sigma an cos nx plus sigma bn sin nx, where n runs from 1 to infinity, will be written as A naught is 0, 0 by 2 plus all this an are 0, right?
Yes,
And
sir.
okay, and what about bn? B1 is 12 divided by pi. B2 is 12 divided by 2 pi. B3 means 12 divided by 3 pi. Is it clear?
Yes, sir.
Yes,
Okay,
sir.
so that it is 12 divided by pi cos x. B2 is, since it is 0, it is B3, it is B5. B2, B4, B6 is 0, and it is 0, then its B3 is 12 divided by 2 pi into cos 3x plus 0 plus 12 divided by 5 pi into cos 5x. This is the Fourier series part. Okay, this is the Fourier series here we are having. So my f of x is nothing but, here we are having, so 12 divided by pi cos x plus 12 divided by 2 pi means it is here it is 6 divided by pi cos 2x plus it is 12 divided by 5 cos it is 3x, and here it is 5x, like that it goes on. Okay,
Yes,
Yes,
sir.
sir.
so this is the Fourier series part, and from this problem, so it is a wave of sine from 0 to pi, and then it is pi to 2 pi, it is 0. So that if I am computing the Fourier series for this case, the Fourier series, it is pi form, am I right?
Yes,
And in,
sir.
and the interval, it is defined which interval?
0 to 2 pi.
0 to 2 pi, and don't consider it is 0, so we have to ignore. Don't take it as in that way. It is starting value is, by the graph itself, it is 0 to 2 pi only. So period,
2 pi.
actually 2l is 2 pi minus 0, which is 2 pi, then l is pi. Period is 2 pi, L is pi. Am I right? So pi form. So the required Fourier series f of x is a naught by 2 plus sigma n runs from 1 to infinity a n. Can you tell me here what I have to write here?
Cos n.
N x1, which
Nx.
is pi. Okay, are you got the point?
Yes, sir.
Okay, now a naught, which is 1 by pi, interval from 0 to 2 pi, 0 to 2 pi, my f of x into dx. So 1 by pi, 0 to pi, which is sine x, okay, sine x dx plus pi to 2 pi is 0 into dx. That's all. So that 1 by pi minus cos x, which is 0 to pi. This is 0. Okay, this is 0, and this is 1 by pi, 1 by pi. So can you tell me, this is minus cos pi, minus of minus, it is 0, cos 0. So what is that? Cos 0 is 1, cos pi is minus 1. Overall it is 2 by pi. Is it clear?
Yes, sir.
Okay, then an 0 to pi, 0 to pi, my function itself sin x, and this is cos nx dx plus pi to 2 pi, my function defined it is sin x, and this is sin nx dx. Okay, it is the case. Just integrate. This is how can we integrate? How can we integrate, Bob? We have to take the product to some formula, right?
Yes, sir.
Okay, tell me the formula. A plus B, A minus B, cos or cosine?
1 by 2 into sine of A plus B
1 by 2
plus
sine.
sine of A minus
So product to sum formula we have that, right? Sin A cos B is, what is the formula here? Sin A cos B is 1 by 2.
1 by 2 into sine of A plus B plus sine of A minus B.
Let's check, otherwise the answer will be wrong. Here we are having this one only. Because otherwise we will waste our time. That's why I'm checking. So what is that for? Sin A cos B, okay? Product to sum formula. Do you have that? Sin A cos B, right? Sin A cos B means
Yes,
sin
sir.
of A plus B plus sin of B, right? It is right? Sin of A plus B plus sin of A minus B. So that this can be written as 0 to pi. Half of the time sin of A plus B means sin of this. Here it is 1x, here it is nx, so that 1 plus n into x dx plus the same 0 to pi. This is sin of 1 minus n into x into dx. Okay, now it is 1 by pi. This pi I will take as common, and here it is 1 by 2 pi to 2 pi interval. Okay, sin x into sin nx means okay, sin x into sin nx means, so it is sin of A plus B means again 1 plus n. Am I right? No, it is sin A sin B. Sin A sin B. Sin A sin B means 1 by 2 cos of A minus B minus cos of A plus B. 1 by 2 cos of A minus B minus cos of A plus B. Is it right? Let's check.
So pi to 2 pi the function is 0 only, no, sir?
Why pa? Oh, it is not defined.
It is defined as 0, sir.
It's 0, sir. It is defined as 0.
Okay, then our job is very easy. Job is 0. No need to consider these things. Yeah, you are right. So just integrate this. This is 0, right? This part is 0. This part is becomes 0. So remaining it is 1 by 2 pi sin of 1 plus nx. It is minus cos of n plus 1 into x divided by n plus 1. It is from 0 to pi plus minus cos of 1 minus n divided by 1 minus n. It is also 0 to pi. Okay, so now it is 1 divided by 2 pi, 1 divided by 2 pi. So just substitute the limit here. Minus 1 divided by n plus 1. I just take outside of this. This is cos of n plus 1, or shall I take in this way, n pi plus pi?
Yes.
Okay, now
Yes, sir.
this is, suppose this also I may take in the plus format. So it is 1 divided by n minus 1. Okay, which is cos of 1 minus or pi minus n pi minus cos 0. Okay, cos 0. So it is 1 divided by 2 pi, 1 divided by 2 pi minus 1 divided by n plus 1. Cos n pi plus pi is what? Okay, 0, pi by 2, pi, and then it is 3 pi by 2, and then it is 2 pi. Okay, so suppose I am having this n pi plus pi, or simply you may consider in this way, cos A cos B minus sin A sin B. So what is that? It is 0, right? So cos pi is minus 1. Cos n pi is minus 1 to the power n. overall it is minus 1 to the power n plus 1. Is it right?
Yes.
That cos of n plus 1 into pi means it is, we treated it as n, so minus 1 to the power n plus 1. Simple formula. So that this term will be written as it is minus 1 to the power n plus 1 minus it is 0. Okay, so in this way we may write. The next one, n pi 1 minus n is 1 minus n is 1 minus n is, it is cos of pi minus n, means it is cos a cos b minus sin a sin b. Okay, it is 0, it is 0, remaining it is minus 1. This is minus 1 to the power n. This also minus 1 to the power n plus 1. So cos of 1 minus n into pi also 1 minus n minus 1 to the power 1. So 1 divided by n minus 1 into this minus 1 to the power n plus 1 minus 1. So this is the case here we are having. Okay, sir. Now this is my an part, right? This is my an part. So shall I segregate this as this when n equals to 1 case or not equals to 1 case?
Yes.
When n not equals to 1 only, it will be true, pa. Okay, before that I just consulted few things. Okay, few things, because this 1 divided by 2 pi, suppose I am going to take this as common part, this minus 1 to the power n plus 1 minus 1, which is common in the both the terms. So remaining it is minus 1 divided by n plus 1, then 1 divided by n minus 1. So that 1 divided by 2 pi minus 1 to the power n plus 1 minus 1 into this, taking the LCM, minus n plus 1 plus n plus 1 divided by n square minus 1 square. So what we are having, that in the numerator it is 2, then that 2 and this 2 will get cancelled. So that 1 divided by pi minus 1 to the power n plus 1 minus 1 upon this n square minus n square. So this is my an, and this an when n is odd, when n is even, when is odd, can you tell me when n is even number? This will make it as an odd number, right? When n is even means this will be odd number. So it is minus into minus. So minus minus 1. So minus 2 divided by this. This structure will be, minus 2 divided by n square minus pi square. When n is odd means it will an even
So
number.
can we scroll up for a second? Yes, sir. Okay.
Okay, ma. So when n is odd and even, odd means it is here it is positive 1 minus 1. It is 0. And please remember that is this only two possible cases we have to discuss in this an? Will it enough? But n equals to, n not equals to plus or minus 1. Okay, because when n equals to 1, this tends to 0. When n equals to minus 1, this tends to 0. Is it clear?
Yes, sir. So like an will not be defined for n equals to plus or minus 1, sir.
What, ma?
So an will be not defined for n is equal to plus or minus 1,
No,
right,
it is
sir?
not defined. It is not defined. Okay, but not defined. See here it is, why it is happened. This is actually here it is plus or minus 1 case. We are assuming that from this n square, but it is n is starting from yes, positive number only. So that when n is equals to, when n equals to 1 only, here we are having, because n starting from this 1. So okay, why it is not satisfied, because this 1 upon this n minus 1 happened. Is it clear?
Yes,
Okay,
sir.
in this case, this is the general case for n equals to 2, 3, 4, 5, 6 up to infinity. But this a1 should be calculated separately. Okay, this formula won't work. This is the generalized formula. So in general, what is my an? An formula. An formula. What we are having that an formula. An means this is pi form or L form. Pi form. Okay,
Right
a
form, sir.
n means it is 1 by pi 0 to 2 pi 0 to 2 pi. It is f of x cos nx dx. Substitute here n equals to 1. So cos x only. Okay, cos x only we are going to compute separately. Cos x only here we are going to have separately. So that 0 to what is the 0 to pi 0 to pi, it is here, it is sine x into cos x only. Here n is 1 plus pi to 2 pi, it is 0 into cos x into dx. Is it clear? So sin a cos b formula again, sin a cos b formula again. Sin a cos b is what? Sin a cos b
Sir,
means sin a plus, yeah ma?
so why are we finding A1 separately, sir? Now,
See ma, when n equals to 1, if you are substituting, what we are going to have this tends to
okay, sir, I understood now.
this tends to infinity, but we need some finite values of that, or at least we have to
Oh,
show it is 0.
okay, sir,
Okay,
I got it.
okay, we need the finite value. So it is sine of a, sin a cos b means it is 1 by 2 sine of a plus b plus sine of a minus b. So what about this 1 by 2? 1 by 2 sine of a plus b means it is sine of 2x sine 2x dx plus again the 0 to 2 pi sine of a minus b means sine of this is x minus x into dx. So it is sine 0 0. So it is overall it is 0. Remaining it is sine 2x if you are integrating. So what will be the answer? It is minus cos 2x by 2. It is 0 to 2 pi. Okay, so this 2 and 2, so it is 1 by 4 pi minus of this. So cos 2 pi minus cos 0. So what about this cos 2 pi? Cos 2 pi value is 1. Cos 0 value is 1. So overall that, which implies that now this a1 is 0. Okay, but what you obtained here when a1 is infinity. Okay, to avoid these conditions we need to get this one. Okay, then bn I have to calculate. Okay, so this maybe you may taken it as homework. Okay, so here this b1. Okay, this b1, here we are having that bn is 1 divided by pi. It is 0 to pi. F of x is, here it is sine x into sine nx dx plus this pi to 2 pi. It is 0 into sine nx dx. So what about the sine a, sine b? Sine a, sine b? I think I raised cut it. Okay, sine a, sine b means 1 by 2 cos a minus b minus cos a plus b, right?
Yes, sir.
Okay, use that formula. Sine a, sine a, sine b is 1 by 2 cos a minus b minus cos a plus b. If we are using that, okay, a minus b means it is sine of 1 minus n into x dx plus 0 to pi. Sorry, it is cos of, sorry, cos of cos of, then it is cos of 1 plus n into x dx. Okay, now it is 1 divided by 2 pi. It is minus, not positive, positive sine of 1 minus n x divided by 1 minus n, limit from 0 to pi. It is sine of 1 plus n divided by 1 plus n. Okay, 0 to pi. Okay, so that it is 1 divided by 2 pi, 1 divided by 2 pi, sine n pi 0, right?
Yes, sir.
Okay, sine of 1 minus n into pi divided by this 1 minus n minus this sine 0 plus 1 divided by 1 plus n into sine of 1 plus n into pi minus sine 0. Okay, these two values are 0. Then what about the sine 1 minus n pi? Sine 1 minus n pi, which is sine of pi minus n pi. Sine a minus b means, okay, I may consider it as sine of 1 plus of minus n pi. Okay, sine of a plus b. Then sine a cos b minus cos a sine b. Is it right? Sir, is it clear?
Yes, sir.
Okay, then what will be the value for this? Actually, it is sine pi. It is sine pi. Sine pi. Sine a cos b, then cos a sine b. This is sine pi. Okay, sine pi here it is 0. Sine n pi here it is 0. Overall it is 0, right?
Yes, sir.
So yeah, definitely sine a cos b, then cos a sine b. So these two things, sine 1 minus n pi and the sine 1 plus n pi, both are, it is 0. So my bn will becomes 0. So my Fourier series, if I'm computing this, f of x is a naught by 2 plus and this a1 cos x I have to write separately. Remaining it is n from 2 to onwards, an cos nx plus sigma n from 1 to infinity bn sin nx. Okay, do you know that why I am writing this separately? Do you know that? 2 by pi. Students, it is 0. My a1 is 0 and this an is for, an is also divided for only the even number. Odd number is, it is 0. So that here we are having that, I may have that this is also we can segregate into two sections, namely sigma n from odd numbers only. Okay, odd numbers only, an cos nx, sigma n is only even numbers an cos nx. Okay, what is odd number? When n is odd in your series, when n is odd means it is 0, right?
Yes, sir.
Okay, so overall that is 0. Overall it is 0. Remaining when n is even means when n equals to 2 comma 4 comma 6. If for these numbers it is minus 2 divided by n square minus 1 square into pi. So remaining it is cos nx plus my bn becomes 0. My bn is 0. So the required Fourier series is, it is pi minus 2 divided by minus 2 by pi into, actually minus 2 divided by pi, it's irrespective of the summations. So minus 2 divided by pi sigma n from 2 to 4 to up to infinity 2 comma 4 comma 6. It is cos nx divided by n square minus 1 square. Okay, I hope you understand how we are computing the Fourier series. Got it?
Yes, sir.
Yes, sir.
Okay, ma. Now, an important concept, that is the conditions for convergence. It's also the material. I just added the things. Okay. Do you have the BS Gravel book? Do you have BS Gravel book or Kreisig book? So
Sir,
conditions.
we have BS Gravel, sir.
Okay, pa. And you just practice. Take the examples of that book. Okay, examples of that book, and you may practice. And this only it is given. Okay, see here, conditions of convergence means in some interval minus a to a or 0 to l. So your Fourier series, if you want to ask, it should be a convergence means we are going to have some finite value for that your function, and that first derivative of the function should be continuous or at least piecewise continuous in this interval, this minus p to p. and this if it is any discontinuities arises at some point x, which means that we have to take that left hand limit and right hand limit of that function. See here, why it is nothing but, here it is nothing but some f of x is defined, some functions f of x is defined, okay, 0 less than x less than a and a less than x less than b. Here also some function, here is some function. So at this point I have to evaluate the function value at f of a, means what is exactly the Fourier series will gives us, meaning that I have to take the right hand side limit of this f of a plus and f of a minus, and adding together, taking the average of that, that is the function's value, that is nothing but my convergence value. Is it clear?
So can you explain that one more time?
Okay, I will give I will give you a separate table for that. That is just an introduction part only. I will give you a separate table to you so that you can understand. Okay, so wait a minute. Yeah, so my f of x is continuous. My f of x is continuous in some interval a comma b. Okay, how to compute f of x, meaning the Fourier series value at some point. Okay, you got the point?
Yes, sir.
Okay, so here my f of x is continuous. Suppose this is my interval defined like c to c plus 2l, or 0 to 2l, minus l to l, 0 to 2 pi, minus pi to pi, like that it is defined, or minus 10 to 10, like that it is defined. Then on that interval, I have two different cases. One is end point I may compute, or inside of any point I am going to compute it. Okay, on the worst case, suppose my function in this interval, it is defined as many discontinuous functions. It is one function, here it is one function, here one function, here one functions. Okay.
Yes, sir.
Okay, hope you got this idea by the graphical things. Okay, so f is continuous means with this interval a to b, the inner points I'm going to take it. Any point I can choose it. Any point from this interval I may take it. So that is, it is called, here it is continuous. So simply the answer, how to compute final Fourier series your f of x, how we are going to compute. Okay, so that substitute, it is substitute the value f of the value directly. It is directly. Example, let us take my f of x is x. Sir, my f of x is x. Suppose which is defined in 0 to 2 pi. I want to calculate f of x at x equals to pi by 2. Whether this pi by 2 is belongs to this interval or not.
It belongs, sir.
It belongs to this here. Probably, most probably it is pi by 2. So here it is pi. So here it is pi by 2 as an inner point. So it is continuous. So what they are suggested, my f of x value, that f of pi by 2, if I want to compute, means in my function that x should be replaced by direct substitutions. Is it clear?
Yes.
Yes, sir.
F of pi by 2 value is pi by 2. Okay, this is my first case, sir. This is my first case. And my second case, I am having a discontinuous function. F of x is discontinuous. It is discontinuous. Okay, meaning that in this a to b, okay, this is defined on something like an open interval. Even it is closed interval also. Okay, discontinuous means here this end point is we are not considered. Okay, end points are we are not considered. Okay, on that it is the first case. It's the first case. Okay, so here I may take the choice if it is an end points are. My f of x is end point. This is case 1. This is case 1, and this will be your case 2, and this will be your case 3. Case 2 and 3 under discontinuous functions. Okay.
Yes, sir.
Okay, case 2 and 3 are under discontinuous. So endpoints means average value of or average value at the endpoints. Average value at endpoints. So what is the meaning? What is the meaning? Just consider this f of x. F of x equals to x square, which is defined on, suppose this is, here it is minus pi to pi. Minus pi to pi. So we know that this is my x square graph. Okay, this is my minus pi and this is minus pi. So either I have to evaluate the function's value at this pi or this pi. Is it clear? The end point we are going to compute. Periodic means from this minus pi to pi, again the graph going to have the same nature. Don't look at that, it is going beyond that. Okay.
Yes, sir.
Okay, periodic means definitely the same graph should be come. Okay, now here it is. Here it is f of x equals to x square minus pi to pi. So average value, so that my f of x at either x equals to minus pi or x equals to pi, the formula will be averaging of this function value at divided by 2. Okay, first substitute this minus pi here, then pi here, then we have to compute the minus pi whole square is, it is pi square, then this will be pi square divided by pi square, so it is overall it is pi square. Okay, is it clear?
Yes, sir.
Okay, now I just slightly modifying the functions to get the better understanding of this. Okay, to better understanding of this, since this example all this f of pi minus pi, then all these values are will gives the same value. Okay, if it is x in this 0 to 2 pi, I'm going to compute. Now the formula will be changed into in this way, right? You are going to find f of x at either in 0 or 2 pi, any one of the things. It is called endpoints. Endpoints. Okay, so what will be the formula? It is f of 0.
F of 0 plus f of 2 pi by 2.
So f of 0 is what? 0. F of 2 pi is divided by 2. It is pi. Here you have to notice that this f of 0 and this f of 2 pi is not same. Am I right?
Yes,
Even f
sir.
of 2 pi is 2 pi. F of 2 pi is 2 pi. So this value, you are taking the average value of your function series, your Fourier series value. Here we are going to calculate the average value of that end points only. End point, see, it is my x square value 0 to 2 pi, 0 to 2 pi. This is my x and this is my f of x, the given functions. So at either I want to compute the value of this 0 or this the value. Actually the meaning is f of 0 is 0 and f of 2 pi is, this is my 2 pi, right? This is my 2 pi. The height will be here, it is 2 pi. But in Fourier series, at the end point, if you are evaluating means the average of that, here we are going to have it. Averaging value of these functions only we are assuming it. Is it clear? Not at
Yes, sir.
not at exactly the same point. Exactly the same point if you are substituting means your function should be continuous. Okay, now it is middle points are middle point. So what we are going to meeting is this middle point. Already I told that a less than x less than b and b less than x less than c. Then at this b here we are going to compute. Okay, so this is called middle point of my interval. So this is my a and b, this is my a and b, this is a, this is a and this is c, and this b and this is C. At B we are going to evaluate. At B we are going to evaluate. So then formula is left hand limit plus right hand limit limit divided by 2. That's the case formula. Consider f of x equals to this function x when 0 less than x less than pi and x square, and this is pi less than x less than 2 pi. Okay, so shall I take this place? Okay, now consider, take the f of x plus. What is mean by f of pi minus? So we are going to evaluate at the point, which point? Pi, right?
Yes, sir.
So f of pi minus f of pi plus. This is my left hand limit for this interval, for this function, and this is the right hand limit at this point pi. At pi we are computing left hand limit and right hand limit. Okay, f of pi minus, the formula will be limit h tends to 0, the function, if it is pi minus h. The general formula for this, it is pi plus h, whatever we are having. What is my function in this interval? Left hand side of this interval, it is x. Am I right?
Yes, sir.
So this is x. So can you tell me that value? This is not substituting, not sufficient. Okay, I will write here limit h tends to 0. This is f of pi minus, this is f of function of pi minus h. Since my function itself x, so that my pi minus h only I am having. Okay, so it is when h tends to 0, it is
This
pi.
is pi.
Then f of pi plus limit h tends to 0, f of pi plus h. What about my function here? It is x square. So that limit h tends to 0, it is pi plus h whole square. Now if you are expanded, pi square plus 2 pi hx plus h square, when h tends to 0, it will be pi square. Is it clear?
Yes, sir.
So
Yes.
now if you are taking the average of these two value, f of pi value becomes, so what is that?
Pi plus pi square, right?
This implies that it is 1 by 2 times of f of pi minus plus f of pi plus pi plus. Okay, so 1 by 2 pi plus pi square by 2. So this is the function value. So 3 ways here we are going to compute the function. Okay, one is discontinuous and another one is in the discontinuous form is at the end point either a or b. Okay, the formula is same, f of a plus f of b by 2 average value, and if it is in the middle point of the functions, if you are evaluating the function value, which means that the left hand limit and right hand limit of the value. Okay, so what is the advantage of this one? Why we are studying? Okay, so that's the next case. Okay, due to the time insufficient, okay, let us consider in this way. Okay, let us take this problem. Sir, this problem, sir. Find Fourier series for f of x equals to 1 by 2 pi minus x. Okay, pi minus x in the interval 0 to 2 pi. Okay, and deduce that. Sir, for this you can compute 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, keep on going till infinity, it is pi by 4. Solutions. So for this Fourier series, you know that one. Okay, so you can solve this, you can get this Fourier series. Okay, you can get. So I will give the general final Fourier series value. Okay, directly I am going to give. So my f of x, the Fourier series will be 1 by n sine nx summation n from 1 to infinity, means where a naught an becomes 0. Okay,
Yes, sir.
Okay, so let us consider this is the answer for this one, this problem. Okay, my Fourier series is over like this. Up to this we obtained. Up to this in the problem we obtained. So what is that we are having? What we have to prove? And this is my this kind of series value. Yes, an infinite series value. Okay, the left hand side having infinitely many values, but it is same as with this pi by 4. How to prove? Okay, using this Fourier series. Using this Fourier series, now we have to pick any point from this interval 0 to 2 pi. From this interval 0 to 2 pi, we have to derive these results. You got the point?
Yes, sir.
Okay, and look at this series in the left side. Okay, look at this series. Suppose I'm going to choose this sine 0. It is entirely 0, right?
Yes, sir.
So we cannot get this series. So 0 is omitted. Like this 2 pi if I am choosing, that also omitted. I cannot choose this pi, that also omitted. Sine n pi 0. This pi is not avoided. So it is not accepted. Okay, suppose I am going to choose this pi by 2 sine n pi by 2, which is 1 only, right?
Yes, sir.
Okay, I may have a chance. So at this juncture, pi by 2, since it is not fall under the many functions, like if it is piecewise function is there, then the third case we may take. Okay, third case we may take. So here the endpoints are not possibility. So two discontinuous points are removed. Two discontinuous points are removed. So the only possibility is continuity case. Even on this also this pi is cannot be used. So pi by 2 can be used. Okay, so at x equals to pi by 2. Okay, put x equals to pi by 2 here x equals to pi by 2 is point of continuity. Am I right?
Yes, sir.
In 0 to 2 pi. So how can we compute, right, this f of x value at x equals to pi by 2? It is direct substitutions, right?
Yes, sir.
Sir,
So what is your function?
sir,
Yes, pa, if you have class, you left.
doctor meeting, sir. Can I leave?
Yeah, you may left, pa. You may see the recorded video. Okay, only this part only I will complete. All the very best for your exam. Okay, so direct substitutions here we are going to do it. Okay, at x equals to pi by 2, at x equals to pi by 2, x equals to pi by 2, so that it is 1 by 2 pi minus pi by 2. So overall it is pi by 2, then here it is 1 by 2. So here we are having that pi by 4. Okay, then consider this equation 1 and this 2 and this 2. Okay, from 1 and 2, we have this f of x is sigma 1 by n sine nx, where n from 1 to infinity, n from infinity, this only we computed as pi by 4. Or you got the point? Where right side we are substituting, it is n pi by 2. Okay, n pi by 2. Now substitute n equals to 1. It is 1 by 1. Sine pi by 2 is 1. Now when n is 2, 0. Am I right?
Yes, sir.
Yes.
Sine 3 pi by 2 is
1 minus 1.
okay. Sine 5 pi by 2 is 1. When n is even, sine 6 pi by 2 is sine 3 pi. See, it is here, it is sine 2 pi, it is 6 pi is 2 pi by 2 means sine pi, and then 4 pi by 2 means it is 2 pi, 6 pi by 2 means 3 pi. So that's why it is 0, this 1 by n. Okay, and keep on, it's going on. So this implies that pi by 4 equals to, what are the members present? 1, which is minus 1 by 3, then plus 1 by 5, minus 1 by 7, keep on going. So this will be equals to pi by 4. Okay, pi by 4. This we have to derive. So in this way, that condition of convergence point you have to use to reduce the series. Is it clear?
Yes, sir.
Okay, some exponential functions and other functions you may practice with your BS Greyval book. Okay, the syllabus is over. Okay, so I will share this material. So this is the one we written everything, right? Which material I have to share? This is the one. So this is not used. Some gap is there. Okay, so you may fill your side. So I record off. Stop the recording.